how to turn a texture plate smooth, Z offset woes, and infill that's not connecting. All this and more, PrintFix Friday, episode 75. Let's get into it. Hey guys, welcome back to the channel. If you're new here, make sure to leave a like and get subscribed. We've been talking all about print failures on YouTube's longest weekly Print Fail Fix video series. Remember, you can send in your fails for me to take a look at by sliding to those DMs on all the social medias, using the hashtag PrintFix, or emailing us directly, youtube@3dmusketeers.com. We have some really interesting fails for you today. Some are a little bit worse than others, but I'm really excited to tell you about our sponsor, 3D Musketeers. If you are struggling with your prints failing, you can reach out to the pros at 3D Musketeers. While we're certainly not going to run our Bambu for you, we've got a fleet of Prussias and a myriad of other machines to help you get your ideas and make them real. We also have an entire team of CAD designers, and we are actually looking to hire some. So if you're in the market and looking for a part-time gig doing some CAD work and you're proficient in Fusion 360, reach out to us. Love to talk to you, make all that stuff happen. But if you are looking to support the channel, you can do so by joining our Patreon or YouTube channel members for as little as $1 a month. And at the $10 tier or higher, gets you to come over and hang out with us in our private Discord, where we share a lot of behind the scenes content, as well as the inner workings of what we're doing and why we're doing it. There's some cool stuff going on there. We totally understand if you don't have any cash to spare. Times are tough these days. I 100% understand. But it doesn't cost a dime to make sure to like, comment, subscribe, and hey, share it on a Facebook group or two. That seems to upset people. But enough of that. Let's get back into today's video. Looking for help finishing my print, we've got an Ender 3 glass bed here. This is the carborundum material. It is commonly just silicon carbide stuck inside of the glass. So be careful with your nozzles dragging on it because it will destroy nozzles. We'll do a video on this eventually. It's sandpaper. I have these items printed up looking to clean the print. It shows discoloration showing the previous print from the print bed. I clean the bed every time with IPA, tried wiping down the finished print with IPA, no luck, thanks. So in a case like this, you are likely way too close to your glass bed. It likely sticks like a hot damn because it's going to. But we can see some things here that are a little bit interesting to me. Looking at the part, it's actually not too close at all, except over here it is, but over here it is quite a bit far away. So we have a bed that is in need of some tramming. We have an entire video on this. We'll link to it so you guys can take a look, of course, in the description down below as well. But this is something that you want to be aware of. When you do print parts like this, it is a chance that it will leave some sort of residue on your print bed. If you are really worried about this, you should make sure that you wipe it down with hot water and dish soap as a way to try to clean it off. But I don't see this happen very often with glass plates. It can happen if you don't have the correct Z offset, but if you really are concerned, flip that plate over to start. That texturized surface, there's really no way to get rid of it unless you sand your part. But the way that we can see the previous parts in here, that is because you have an issue with your Z offset. As we see, as it goes further away, you don't see the detail anymore because the part's not being jammed into that glass plate. You can go ahead and add some glue if you are that concerned with it. The glue should make everything matte, but you will have to either reconstitute the glue every couple of prints or just make sure you're not tearing it off. This is a bit of a compromise, unfortunately, with 3D printing, and it's why we prefer to use PEI flex plates. And you can get ones. There are generic ones available, although I have really been enjoying the Wham Bam PEX plate that we put on our Bambu X1 Carbon. And if you use the code Musketeers 2022, yes, it is still Musketeers 2022, you can get 10% off your entire order over at Wham Bam. The plates are not cheap, but damn do they work well. And when you're looking at trying to get the best quality of print that you can, I highly recommend you move away from the crappy glass beds that come with your Enders and move into something that's actually going to treat you right. A flex plate. They're so much better. What is the plus minus dial for? Also, it doesn't seem to be extruding. The gear doesn't turn consistently. We've got a couple of problems here, and I've learned from you guys. I have remembered to keep an eye out for this. The fan is on backwards. It is pulling air out when it should be pushing air in. So that's the first thing we got to do is go ahead and flip that fan around. But given that this is an extruder, the best thing that I can come up with is that this is some sort of extruder pressure. We do see another kind of knob there as well, but we don't really have any more information than this. So when you are looking to get help with a 3D print and a printer that might not be working very well, it is incredibly prudent to make sure that you include relevant information so that people that are trying to help you kind of know what's going on. In this case, it appears to be a CR10 or an Ender-based machine, likely direct drive from the looks of it, because that appears to be the edge of an Ender Gen 1, because we can see the exposed switches here. We definitely got to move that fan around. That's likely why it's not extruding. And as for this, it's got to be extruder pressure, right? I don't know. Let me know in the comments. What do you guys think? I'm pretty sure it's extruder pressure, but I don't have a machine with this knob on it. I'd love to know what you think. Printer was doing great, and now it seems to go rogue and mess up base layers. I'm not sure what the problem is. I've tried to level the bed multiple times and no luck. Seems like it starts to rapidly dispense filament. Please help, I'm new and this is my first printer. Well, this is something that a lot of newbies will get wrong, and every now and then, even as someone that's been doing it for a minute, I still get it wrong. Clean your bed. Your grubby mitts have oil on them, and that is something that plastic does not stick to very well. If you have taken the bed off your printer, chances are you've probably touched it. And if you're using like your fingernail or something to get a part off the build plate, you're likely going to have issues with parts sticking in that area. When all else fails, hot water and dish soap gets the job done 95% of the time, but this is an Ender 2. From my knowledge, the red beds tend to be Ender 2 beds. You can also wipe it with isopropyl alcohol in between prints, although personally, I use Windex. It just works for me. Do whatever works for you, right? There are plenty of ways to clean a surface. Use what works best for you. The last-ditch effort for me is the dish soap approach because it strips everything off the print bed. You kind of have to start over with whatever cleaning regimen that you use. It's kind of like seasoning a cast iron pan, if you will. But this is likely just an oil issue. No big deal, pretty easy fix. Get that bed cleaned and life will be good. Seeking advice with no further information. All right, let's take a look. You got a Z offset problem. We did a video recently all about Z offset, and if you guys remember that video, which we will card to so you guys can take a look at it, this is too far away. We have a valley in between our print lines, which means we got to bring that nozzle closer to the bed. Depending on the printer, that might be adjusting the baby steps on the Z axis, or it might be adjusting some wheels if the machine does not have an auto bed leveling probe on it, or if it does, some printers still have that. But this is a really easy fix. It's a trap for young gamers that are brand new to this because it's not all that obvious how to fix this problem. Get the nozzle closer by either getting the actual head closer or the bed closer to the nozzle itself. It's a very simple fix, and I prefer to do this kind of stuff on the fly. I'll make a part, maybe a bench here, something with a really big brim, and I'll just adjust the wheels until it works. Alternatively, you can use the PrintFixFriday bed leveler as well, which is easy mode for this kind of thing, and will get you pretty much a perfect first layer every try. And for 25 to 30 bucks, that's a steal as far as I'm concerned. Fragile at the top. We've got a Ender 3v2 here. We've got a custom cooling solution. They're printing a roller assembly for their filament, and the rounded parts at the top of the print broke off with the slightest touch, except one. And I noticed some perforated layers at the end of the print, the connected box area. So probably over here somewhere. PLA at 220, bed at 60, fan speed 100, printed inside detached garage, 68% humidity, 75.3 degrees freedom, and it's printing at 120% speed. Well, okay, we might be getting very close to our speed, and going that little extra percentage is going to throw it off. I'm not certain. The bottom of the connected box is from when I had to reset the printer due to nozzle too low temperature warning. I just turned it off and on again and it kept going. I'll change the thermistor later. How do I go about diagnosing the issue properly so I can fix it? First, change your thermistor. If you're getting that warning, it's either because you have a heater failure or a thermistor failure. So don't ignore that. Please get that fixed, because if you don't, it can cause problems. Thankfully, the Ender 3v2 has all the safety features that you would need, but there's really no point in testing them if you don't necessarily have to. Looking at the part here, we've got a classic example of printed parts printed in the wrong orientation. And for this particular piece, I really don't know if there's a better orientation to print it in, to be honest with you. But if you do have a thermistor that is causing you problems, it could be that it's now printing a little bit too cold. 75 degrees freedom? for a garage in where I'm at is cold. My garage during the day right now is probably somewhere in the range of 110, 115 degrees freedom. For all of you that use real measurements, that's quite a bit more than 30°C. It's very hot. So you shouldn't have problems. If anything, you should get better quality prints. But 3D printing is weakest about the Z-axis. As the hot end prints, okay, it is doing layers that connect over and over again. That connection is pretty much the weakest part of it, right? Because it's no longer homogeneous. And when everything is homogeneous, you get strength, right? That's why you get strength in perimeters. It's hard to break apart like this, but it's easier to rip apart the actual strings themselves. So this is kind of a case of this part's kind of not a great orientation to print. You might be able to print it standing up to give you a little bit more strength. It looks like you might be able to get away with that, but I'm not certain exactly what would be the right orientation for this. But I can tell you, it's not this. We can also see that there's some under extrusion issues going on here. Either the printer's gotten too cold or it's gotten too hot. And if you have a low temperature warning, don't keep printing. We can see that it's warping up from the edge of the bed as well. It's really stringy. Could be a humidity issue, but it's probably more likely a retraction issue. And we just have kind of poor quality printing all around. This happens, and it's okay. But going through your printer, making sure things like your V-wheels are tight, your bed is tram, and that you're getting a good first layer are all incredibly important to make sure that you can be printing without all this frustration. I get it. It sucks. But this part definitely needs to be oriented a different way or sliced and printed in multiple pieces and then assembled together with something like 3D Gloop, which is a chemical adhesive. It's actually pretty darn strong. It's cool stuff. I would scrap this. I would look at fixing your thermistor and trying it again. That might solve a lot of your problems without any of the extra BS involved. I would look at making sure your V-wheels are tight because I can definitely see some wiggling here, although I don't know if that has to do with the temperature of your hot end fluctuating like crazy. Who knows? Fix that thermistor first, retry the print, and let's go from there. Next up, we got a submission. It's one of the first print fails I've seen from an AnkerMake, because I don't really see a lot of prints from an AnkerMake, but we're gonna be seeing some from an AnkerMake because we're actually gonna be unboxing one in the coming weeks. We had a very generous Patreon by the name of Russ donate one to the channel, so we're gonna be doing a live stream unboxing and first print on it. So I'm excited to take a look at that machine because the Bambu and the AnkerMake kind of came out around the same time. I'd like to see how the two titans of fast 3D printing kind of compete up against each other when you're looking at an off-the-shelf solution. But this is from Patreon member The Nocturnist, who is having some issues with their AnkerMake. It's not producing great parts, and looking at it, it's a pretty obvious thing to me. It collided with the infill. It can happen, especially when you're not having enough temperature. And when you don't have your infill lines connecting, it is absolutely indicative of not enough temperature. Turning it up a little bit would absolutely solve your issue, whether it's 5 to 10°C, give it a shot and see what happens. If you're not sure about your filament, just run a temp tower. It's cheap insurance to make sure that you know what temperature you should be running your filament at. But if you do notice this during your print, that your infill lines really aren't connecting, you can either slow down your printer or turn up the temperature. Both of those would basically solve the same thing. You need to decrease the amount of pressure that is being created inside the hot end and be able to get the plastic flowing better. If you slow it down, you give it more heat because it's staying in the hot zone longer. If you keep it at the same speed and add more heat, you're still giving it more heat. The issue is heat. It wants more heat. It's a pretty simple problem, but one that you could fight if you don't really know what you're looking for. There could be issues with travel and all of that, but because this is pretty consistent across the printer, I'm gonna go ahead and go with your temperature. It could also be slightly over extruding, and looking at the layers, it's not impossible. And that could be causing the printer to be hitting these lines here, making it not able to print solid lines. So check your extrusion multiplier as well. Make sure steps per millimeter are set correctly. I believe that Anker would do a good job setting it from the factory, but hey, a little sanity check never hurt anybody. Next up, a fail from our Discord as well by Rod, who sent these pieces, and he's looking at different orientations to try to get a good print on these parts, whether it is ABS, ASA, or PETG. He's still having issues where this tall, wiry part is getting hit by the hot end and basically getting knocked off. And we've talked about this before, where the Z-axis is the weakest. And this part it's kind of rough to print no matter how you look at it. So when you are doing a tall print like this, make sure you have lots of Z-hop on, especially if you're only dealing with 2 little pillars like we are here. That should at least get you closer to a guarantee that you're not going to collide with the print itself, causing this failure. But I've seen this happen. It is a common problem, especially if you don't have enough Z-hop. We recommend at least double your layer height, but if you want to go more, it's totally fine. It'll increase your print times ever so slightly. I wouldn't worry about it whatsoever personally. Next up, it is definitely wet filament. This comes from one of our Patreon members, Duff, who, well, had a bit of a problem. This is not Duff's fault. It was the next door tenant whose building caught fire, and unfortunately, it spread to the building that he works for. And, well, for those that don't know, it's not really the fire that really causes damage in a structure fire. It's the tens of thousands of gallons or liters of water that are applied to it. So we definitely have a case of wet filament. Unfortunately, when he was able to inspect the damage, the Voron that they have there was completely crushed when the fire department had to push in the wall to get more water into the building to try to maintain as much of the structure as they could. A structure collapse is way more dangerous, and at some point, you don't really worry about the interior of the building, you worry about the safety of the fire people. And while this isn't exactly a failure in the sense, and it is kind of funny because he deliberately took this photo to say this time it's actually wet filament, it's prudent to know that you do gotta understand your surroundings as well. Also, gorgeous photo. And of course, they have underglow on the ladder trucks. This is a big fire, for those that don't know. I'm glad that nobody was injured during this and that it's just stuff. Stuff can be replaced. Humans can't. Not easily, currently. Subject to adjustment later in the future, I guess. But this hurts my heart because a lot of good printers and good filament were lost that day. But thankfully, no lives were. And that's really what matters. As we can see, there's a fair bit of water in this building. There's your water line for how much water they pumped through. You can see all the soot and ash and just damage. This is what happens. And it's why I warn people about cheap 3D printers. While this wasn't caused by a 3D printer, it absolutely could have been if you're running a printer without any of the safety features. So please be safe and minimally, at least have some smoke detectors around your machines. If not, have a wham bam cloud, which we're going to be testing in an upcoming video, where I actually deliberately set fire to a printer. Again. Next up, a Bambu failure. One of mine. This is part of the video that came out on Wednesday, where I was trying to print lemons in my Bambu because I firmly believe it's a lemon. And this was the first time that spaghetti detection had ever worked for me, and I laughed because it spaghettied down here, but then it recovered itself, and it thinks that there's spaghetti. I don't know. I did click resume because I wanted to see what would happen, and yeah, just knocked the print off. Hilariously though, it did not detect this failure. So the spaghetti detection detected something that was looking totally fine. My guess is that it was seeing all of the tree support here and thought it was spaghetti, but it never bothered up until the print started looking good. I don't know, guys. I haven't had great success with the AI fail detection on the Bambu, but I thought it was interesting to talk about this one with a little bit more detail. And I think I might understand why this failure specifically occurred. We can see some extra material here, and I can tell you that is PETG. So there might have been some PETG still around the hot end, creating some sort of drag. But as for why it started to under extrude and then randomly fixed itself, I have no clue. I would send Bambu my log file, but they are completely silent on what's in it, and I don't really have an easy way to read it. And so until I know what is being sent when I send a log file to Bambu, they're not getting one from me. And if they happen to be able to have access to my printer without my consent, we've got way more issues to be worried about. But that's speculation. What I do know is I'm not comfortable sending a log file that I don't know what's on it. And as we can see earlier on in the print, it's all turned on. I took this screenshot. I pulled up the print option so you could see that the AI fail detection is actually turned on to medium. It should have recognized this. This is clearly a problem. And something like Obico or 3DQ or even Octo Everywhere, any of those would have caught this. Any other AI fail detection software that exists out there for 3D printing would have caught this. I would almost guarantee it. Maybe the AI monitoring was taking a union mandated break. I don't know. This was a little frustrating, but I said, you know what? I can see it's failing. I'm just going to send it and see what happens. You can see the chambers at 39°C, well below the glass transition temperature of PLA. We can see the bed is set to 55, and the hot end is up to 230. This material we found printed better at 230. And when you print hotter, you shouldn't have under extrusion. If anything, you'll have an over extrusion problem. Moving on, we've got the fastest way to turn your textured PEI plate into a smooth plate. This comes from Patreon member Devoid Colossus and was posted in our Discord. Remember, if you want to join the Discord and come hang out with the other Musketeers and myself, you can do so by joining at the $10 tier or higher. This is someone who's running an E3D Revo that I don't think screwed the nozzle in all the way, and it looks like it was just dragging around the printer. And I will give the Revo some credit here. It doesn't look like it's bent. Kudos. But unfortunately, there's no easy way to fix this. This print bed is destroyed. Unless it's double-sided, best of luck to you. You might still be able to get away with printing on it, but you're absolutely going to have that artifact in every print that goes over that area. So remember, before you just send it and walk away, make sure your Z offset is good, even if you're using something like a Revo, where it should be pretty easy to get the Z offset perfect even when you change nozzles. Every time you change a nozzle, always check your Z offset, make sure your first layer looks good before you walk away. It would save you quite a bit of money because this does not appear to be a small build plate. But let me know what you all think in those comments below. A lot of interesting fails this week, and I do want to look at potentially doing one video a month where we dive into a very specific type of failure. Let me know if that's something you guys would want to see. But that's all I have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Hey, thanks so much for watching this video, and a massive thank you goes out to all of our Patreon and YouTube channel member supporters whose names are listed right next to me at the $5 tier and higher. Thank you all for what you do, making these videos possible. Remember, if you want to join, click those buttons in that description down below. Support us for as little as $1 a month. Right below me will be the entire PrintFix Friday series where you can look at failures of mine and others, see how we look at tackling them. Sometimes we're right, other times we're not. That's few and far between. Right next to that will be the entire printer maintenance playlist. Go take a look at it, see how you can keep your printers running right. I will see you all down in those comments, and in the next one, take care.